This is 4.1 exponential functions. So an exponential function, we've talked about this before, but here's, this is generic example. So a to the x power, and notice the exponent is the variable. And notice the, where a is greater than 0. So, we might have, 1/2 to the x power, or we might have 3/4 to the x power, or we might have 2.5 to the x power, but notice the base is greater than 0. So that's what we're going to refer to as an exponential function. So let's evaluate some of these. And here it says, here's an example. So f of x equals 3 to the x. And if I ask you to evaluate the function, so here's f of 5. So this literally is 3 to the 5th power. And then on your calculator, or if you don't have a calculator, 3 times 3 times 3 times 3 times 3, you got to get your answer. So 3 to the 5th power is 243. And here, f to the negative 2/3, so 3 to the negative 2/3 power. And again, if you're not 100% sure how to do this on your calculator, if you forget your calculator, a negative exponent means to flip. And you could sit here and do it that way and then evaluate it without the calculator, but then it gets sometimes like the cube root of 3 and then squared. So there, you would have to be working at this for a while, but just plugging this into your calculator, 3 to the, now, something I do want to point out to you is if you have a, on my TI-84, I can plug in to the negative 2/3 power and it looks exactly like the problem. So just be careful when you plug this in. So when you, on your calculator, make sure you plug the fraction in with parentheses. If you don't do that, if you just type in this, the calculator will end up doing this first, and then it will divide the whole thing by 3. That's not what you want to do. You want to take it to the negative 2/3 power. So make sure that you remember how to use your calculator to make sure that you use parentheses on a fractional exponent to be able to do that. So you're going to end up getting 0.48. And notice the directions. It doesn't say, but the directions on your homework or something will tell you to do 2 decimal places or 3 or 4 or 5. So just pay attention to the directions. So here I'm just going to round to 2 decimal places, 0.48. And then again here, f of pi, so this would be 3 to the pi power. And so you would just type that in. So again, make sure you know how to do this on your calculator. So make sure you know where the pi is on your calculator. And remember, don't round until the very end. Okay, so never round within a problem to be able to do that. So especially if it said like 5 decimal places, and if you just happen to type in 3 to the 3.14 power, notice it gives you a different answer. So I want to be very clear on this. Don't round a problem until the very end. All right. So a lot of times we use 3.14 as the pi, but that's a rounded answer. So here 3 to the square root of 2. So 3 raised to the square root of 2. And that's going to give you 4.73. And again, I'm just rounding to 2 decimal places on each of these. Let's look at how to graph functions. Now, here I want to point out something. Notice the base is bigger than 1 on this problem. So this is 3 to the x power. This is 1/3 to the x power. And I want you to notice these are both exponential functions, but notice here a is greater than 1 here. A here is less than 1, but remember it's still greater than 0. All right. So notice how that's going to affect the graph when you do this. So I would just recommend doing an XY chart. If you plug in 0, so 3 to the 0 power, anything to the 0 power is 1, so 0, 1. And again, if I did the XY chart at the same time here, so if I plug in 0 here, so 1/3 to the 0 power, I'm still going to get 1. Now, when you plug in the next variable, 1, so 3 to the first power is 3, so 1/3 is right here. And plugging in the next number, 2, so 3 squared is going to give us 9. So plugging in 2, I'm going to get 9. And then let me come over here to this other one. If I plug in 1 and 2 here, so if I plug in 1/3 to the first power and 1/3 to the second power, I'm going to get 1/3 and I'm going to get 1/9. So notice it's going to get really, really tiny. And let's plug in a negative number. So -1, so 3 to the negative first and 1/3 to the negative first. So remember, exponents flip it. So this is going to give us 1/3, whereas when I plug in -1 here, this is going to give me 3. So -1, 3, and then here I put -1, 1/3. So you can kind of see what's going to happen. I'm going to get really, really, really tiny here. It's going to get really close to that X line, but it's not going to actually hit it. Exponential growth, a good example is it starts off really tiny and it grows, kind of like bacteria or population or something like that. Whereas this is exponential growth, an example of exponential growth when a is greater than 0, and this is an example of exponential decay. It's really, really tiny. So this is decay. So whenever the base is less than 1, then it's a decay function, and when it's greater than 1, it's a growth function. So let's look at kind of changing the pace a little bit, but let's look at compound interest. You should have done this in a prior class. So here you have a formula that we're going to use for compound interest. Now, compound interest, just imagine what's happening is if you go to a bank and you drop your money off at a bank, and so let's use an illustration of, let's say we took $1,000 in and we dropped it off at a bank, and we came back 1 year later, and let's say it's at 5% interest, okay? And we came back 1 year later and we said, Mr. Banker, can I have my money back? And the banker gives you your money back, the $1,000, plus he gives you interest. And again, this is just calculated once a year. Let's just say that's how the banks do it, which is not really what happens. But just to explain compound interest, then you calculate your interest, and this is $50. So the banker is going to give you the $1,000 plus $50 extra, and he kept your money safe, but he's giving you the money, letting him keep your money safe. And so you, at the end of the year, you say, Mr. Banker, I changed my mind. I want to keep my money in there for another year. So the second year, you actually start with $1,050 because you still have the $1,000 in there, plus the banker gave you $50. And then you just calculate it again, and you figure out how much the interest rate, and then how much it is. And then if you want to keep it in another year, then you add it to that. And the process keeps going on year after year. Now that's the idea of compound interest. Imagine it only happening once a year. The banker calculates the interest once a year. But that's really not what happens in real life. Banks often calculate it every quarter or every month, and sometimes daily. So what you have to do is calculate it based off of how much it happens per, however often it happens per year. So make sure you understand these terms. So the P stands for the principal, how much ever money you're investing. Here it was $1,000. The rate is the interest rate per year. Now notice it has to be as a decimal. And N is the number of times compounded per year. So that's where you got to really pay attention to. And of course, the number of years is T. So the N is I really want to pay attention to that, because the N, it could be once a year, just yearly, or it could be semi-annual. So let's take note of this. So semi-annual would be twice a year. If I said quarterly, that's 4 times a year. If I said monthly, that's 12 times a year. I might say weekly, which is 52 times a year, and I might say daily. And daily would be 365 times. So every single day, the interest is calculated every single day. So you have to know what the N represents. So let's look at a problem here. So here's an example, a sum of $1,000 invested at an interest rate of 12% per year. Find the amounts in the account after 3 years of interest is compounding annually. I want you to do it annually, semi-annually, quarterly, monthly, and daily on this problem. And notice you're going to use that same formula. You're going to use that same formula on every single one of these. So let me walk you through the first one. So the principal is $1,000. So that's what I'm starting with. So 1 plus, and the interest rate is 12% per year, which is phenomenal this day and age. So that's a really good interest rate. So that's going to be 0.12. Remember, enter that as a decimal. And then notice the first thing I want to do is annually, so it's just done once a year. And again, times the amount of years, which is 3. So that's what's happening on the annual. So this is annual. So notice what I did. I paused the video and I went ahead and filled the rest of this out. But I want you to notice. So this first one is annual. This one's done semi-annual. So it's twice a year. This one's done quarterly. So notice the ends are changing. Nothing else in the formula is changing. And so that's why it's important to notice how often it's being done. Monthly and daily. And I really suggest you actually plug these into your calculator. Make sure that you're getting the same values that I am doing, because using your calculator, on a scientific calculator, you have to know exactly how to plug these in correctly, especially like this big one right here, 365 times 3. So you might want to rather do caret and then parenthesis, or calculate this first and then put that up as the exponent when you type the whole thing in. So just be careful, make sure you know how to do it, and make sure you know how to calculate this. And then the other thing I want to point out to you, notice I did round to 2 decimal places because referring to money, we want to round to the nearest penny. All right, so that's an example of compound interest.